In lesson 31, we're going to learn about negative reciprocals, perpendicular lines, and remote interior angles. I want to make sure we know what a reciprocal is. What does that mean when we say that? Well, if we have the fraction 2/5, the reciprocal of the fraction 2/5 is 5/2. And so you simply swap it. And I know when you've used reciprocals in the past, is say you had 2/5 divided by, let's call it 2/4. That's not 2/5. Well, when we divided, we had to divide it by a fraction. We had to multiply by the reciprocal, so we turned that into 2/5 times 5/2. We simply switched the denominator and numerator. And so then you would solve. So those are examples of reciprocals. 5/2 and 2/5 reciprocals. Negative 1/4, its reciprocal would be -4. Because remember, -4 is over 1. That's just implied. We don't need to write that when we write our answer of -4. Or if we have 3, its reciprocal would be 1/3. But notice if it was positive, it stayed positive. If it's negative, it stayed negative. Today we're going to learn about negative reciprocals. Negative reciprocals have the same characteristic of a reciprocal in the fact that they switch the numerator and denominator. But what it means when we say negative reciprocals is we will actually switch it from a negative to a positive, or a positive to a negative as well. So the negative reciprocal of negative 2/5 is positive 5/2. The negative reciprocal of 5/2 is negative 2/5. So we flip the numerator and denominator, and then we also switch the sign. And then a couple other ones that may be tricky. The negative reciprocal of negative 1/4, it would switch, the 4 would go over the 1, and it would become positive. And then for 3, its negative reciprocal is negative 1/3. Now the reason we need negative reciprocals, or the way we're going to use these, is when referring to lines. What we've already said is parallel lines have the same slope, or m. M is our letter for slope. So if we have this graph right here, and we have this line that is y equals 1/2 x plus 2, so its y-intercept is 2 and goes up 1/2, or negative 1/2. That is your line. And then this line is y equals negative 1/2 x minus 3. Notice they are parallel and clearly very straight lines. But they are parallel lines because they have the same slope. Negative 1/2 and negative 1/2. Those are equal, therefore lines are parallel. Now what we're going to look at is perpendicular lines. Perpendicular lines, remember those are perpendicular is where they intersect and make a right angle. Okay, form 90 degrees. Perpendicular lines have negative reciprocal slopes. So this is where we use what we just did here. If we have a line that says y equals 2x plus 1, okay, I drew that out, started at 1, then went up 2 over 1, and drew my line. This slope is 2. Okay, always look at the m, the slope. Then we have a line y equals negative 1/2 x minus 3. Its slope is negative 1/2. Well, 2 and negative 1/2 are opposite reciprocals. I can put that over 1 if that helps you see it. They're opposite reciprocals, so therefore these two lines are perpendicular. And so that's what we're going to do when solving for lines or equations of lines that have a perpendicular slope. So now let's look at an example in 31.1. It says write the equation of a line that is perpendicular to 5, or y equals 2/5 x minus 3 and passes through point 32. Y equals 2/5 x minus 3. Well, it gives us an equation, a linear equation, and we want to know a line that is perpendicular to this one. So how we can find the perpendicular line is we take and use its slope. It has a slope of 2/5. Well, perpendicular is negative reciprocal, so the perpendicular slope would equal -5/2. And so this would be our slope, our new slope that we will use for our line. So now, let me erase this. I'm going to write -5/2 equals m over here. And now we have the point 32. Well, okay, 3, that's x, 2 is y, so therefore in y equals mx plus b, we know that y is 2, m is -5/2, x is 3, and we are now solving for b. I've got one variable we can solve. 3 times -5/2, -15/2. Add the 15/2. I'll add it over here. Actually, I'll just get this down. Add 15/2. So those cross out. And now we are left with 15/2 plus 2 equals b. Okay? We can add these together by giving them a common denominator. Common denominator here would be 2. So we've got to multiply the 1 by 2 and the top by 2. So 2/1 becomes 4/2. So b equals 19/2. Whoops, sorry. b equals 19/2. So we know b, we know m, and that's all we need to do to form a line. Now we just put it in the equation. Y equals -5/2 x plus 19/2. And that would be your answer, and that's how you use negative reciprocals in those problems. Moving on to one more quick concept in this lesson, remote interior angles. We've learned this before in geometry. We're not even going to do any practice problems. I'm just going to make sure you know what they are. Remote interior angles, if you have a triangle and you have an exterior line that goes outside the triangle and forms an exterior angle. This right here is angle ACD, or sorry, BCD. Messed that up. Angle BCD. Well, if we wanted an easy way to find the measure of this angle, all we have to do is actually add angle A and angle B together. Angle A and angle B. So let's say angle A was 50 and angle B was 70. That would mean that angle BCD equals 120. And that's remote interior angles. Yes, you could use triangle sum theorem and do 50 plus 70 is 120. You know that this angle must then be 60 because they must add up to be 180. And then you would know these are supplementary, but notice it works out either way. But that is remote interior angles. Don't need to do any practice problems, but if you come across any of those, you can use that as a shortcut.